absolute value. And you'll see this every once in a while throughout the entire semester. Different scenarios, solving equations, using it to prove some formulas, basic ideas. So, real quick, you should know some about this. Absolute value of 7 is 7. The absolute value of negative 3 is 3. The absolute value of 4 minus 7 is 3. You know what my favorite mistake here is? People think the absolute value changes negatives into positives, right? That's what it's supposed to do. But I've seen people change this minus sign into a plus sign and come up with an answer for 11. Because they're thinking that this sign right here has to change to a plus. Now you got to be careful. Absolute values only affect the sign of a number. Is this a sign of a number? No, this is an operation. So absolute values have nothing to do with operations. They have just to do with the sign of a single value. So this one should equal positive 3. 4 minus 7 is negative 3. The absolute value of that is 3. All right, how about this one? Well, that's supposed to be the square root of 5. I started writing something else. Square root of 5 minus 2. Is it the square root of 5 plus 2? But didn't we just discuss that it can't change the operation? So this operation is minus, you can't touch it. So what do you have to determine?
We'd have to determine the square root and then solve or work the equation inside the brackets and then
Determine that it's...
Then determine the absolute.
Yeah, determine whether it's positive or negative. I need to know if it's positive or negative. So if you're doing a subtraction, what makes it positive or negative?
The biggest, the largest number. Yeah,
if the largest number is in front, then it's positive. If the largest number is in the back, like this case up here, it's going to be negative. So all you have to do is figure out, is square root of 5 bigger or smaller than 2?
Smaller? No, it's bigger.
Bigger.
Because the negative is
Because square root of 4 is 2, so square root of 5 must be a little bit bigger. So if this is a positive answer, how does it come out? Well, when I took the absolute value of 7, you just popped it out as 7. So if I know that square root of 5 minus 2 is positive, it must pop out exactly as it looks, which is square root of 5 minus 2. And you're done. Because it is a positive value. How about 3 minus pi? Hello, irrational numbers. You have to think about it. What would it be? No, which one's bigger?
Pi's bigger.
Pi's bigger because it's 3.14, which is bigger than just plain old 3. So how do I get this to be positive? No. I don't want you touching the calculator. I want you to tell me what the answer is. Which one's bigger? Pi. I want it to be positive, so how do I make it positive?
Pi plus 3.
Why are you changing an operation?
Okay, pi minus 3.
Pi minus 3. Think of it this way. 5 minus 2 is what? 3. 2 minus 5 is negative 3. They're only off by a sign. So if you flip over subtraction, you're actually changing the sign. It's a neat little trick that we're going to use a lot through math. So a minus b is the same thing as negative b minus a. A minus b is the same thing as the opposite of b minus a. 5 minus 2 is the same thing as negative 2 minus 5. If you want to think of it that way. So this is a neat little trick that comes in handy later on. So what if I asked you about the absolute value of a variable? Now things get a little murky. With numbers, it's real easy. I can figure out if it's positive or I can figure out if it's negative. But here, x, I don't know if it's positive or negative or 0 for that matter. So the first thing you have to do is you have to split it up into conditions. Condition 1, we're going to let x equal something bigger than 0. What kind of numbers are bigger than 0? Positive numbers. So when you see some notation like this, the symbolism, Don't read it as x is greater than or equal to 0 because that tells you absolutely nothing. Read it as x is positive. And if we turn it around and look for the other condition, if you see anything that says x is less than 0, you say x is a negative number. And that way you have an idea of what they're really talking about. X is positive, x is negative. All right, if x is positive, the absolute value of x is just x. Absolute value of 3 is 3. Absolute value of 5 is 5. Nothing changes. But if x is a negative number, how do I change its sign to be a positive? In other words, how did I really go from a negative 3 on the left, here, to a positive 3 on the right? What did I do to that negative 3?
You got its reciprocal.
Reciprocal would flip a fraction.
Oh, I'm sorry. My bad.
I took what? Oh, I know, but how do you change a negative number into a positive number mathematically? Multiply by a negative. So this one becomes negative x. So the absolute value of x is x if it's positive. It leaves it alone. It becomes its opposite if it is negative. The opposite of negative 3 is positive 3. So it works out perfectly fine. This is the definition of absolute value. I'm quite sure when you learned absolute value a long time ago, whenever you learned it, it was the distance from 0. That works great if it's a number, but if it's a variable, it doesn't work so well. So this is the true definition of the absolute value. So, where can we use it? Distance on a number line. Most number lines you're used to are horizontal, but they can become vertical. So just be aware of that. So if you have a number line, and you have two numbers on it, 5 and 17. And I'm going to kind of notate it this way. The distance between 5 and 17 is equal to 12. Okay. If I have a number line, and I have negative 5 and positive 17 on it, negative 5 and positive 17, what's the distance between negative 5 and positive 17? It's definitely not 12. Because from 17 to get to just 0, that's 17 units. 21? 22. I was wondering. I can't do calculations either. Is it positive 22 or negative 22? Distances are always, for us, going to be positive. Notice I kind of paraphrase that as for us. In other words, distances can be negative sometimes. Kind of scary. But that's later in life. So, I need to be able to find the distance between any 2 points. Here's A, here's B. I don't know what A is, I don't know what B is. They both could be negative, they both could be positive. One could be negative, the other one could be positive. So I need a similar calculation for these two that'll get me to the right answer, whether I have positive and negative or both positive. So what operation did you use between 5 and 17 to get 12? Subtraction. So I need to use subtraction down here. Now if I subtract these two numbers, what do I get? Do I get 22? What do I get?
12. No, you get negative.
Negative 5 minus 17.
You get a negative 22.
You get a negative 22, but I need to have it be positive. So how do I change a negative to a positive? Absolute value. So the formula for this is going to be the distance between any 2 points on a number line is equal to the absolute value of their difference. The distance between any 2 numbers is going to be the absolute value of their difference. And that way it doesn't matter which one's bigger and which one's smaller. If you knew out of the A and B which one was bigger and which one is smaller, you could fix it and without the absolute values, as long as you went bigger minus the smaller one. But I'm never quite sure which one's bigger and which one is smaller. So this formula works out very well for undetermined values. All right. A couple little side notes. Oh, before we get to that. Evaluation. I have my own little flavor of evaluation, and I like using it because when we get into chapter, I think it's 2, when we start dealing with functions, if you follow my directions for evaluation here, functions become a lot easier when we hit them. If you try to shortcut it and do it 8th grade style, you're going to fall into a lot of trouble when we hit functions. So for instance, if I give you 3x squared y minus z all divided by 2x plus z squared, and I go off to the side and I say, well, x is equal to negative 2, y is equal to negative 1, z is equal to, let's just make them all negative to make it horrible, negative 3. There's actually 2 parts to this problem. There is the expression, the x, y, and z jump, and then there's what they're equal to, their substitutions. Which side is more important? The left, the expression, or the right, the substitution part? A lot of people do. But see, x, y, and z are variables. How many numbers can I put in there? They're variables. An infinite number of possible values. I'm only choosing a specific 3. So this side really isn't that important. What I'm plugging into is much more important. Most mistakes in substitution are not plugging in the wrong numbers. They're writing the expression down incorrectly. You know, dropping a square, dropping a z, forgetting the y, writing it incorrectly, because they're more worried about the numbers than they are about the setup. So my suggestion is concentrate on the setup first and then worry about the numbers, because these things are going to change all the time. So my suggestion is replace all the variables that you run into with an empty set of parentheses. That way you get the format of the problem correct. Make sure you do not drop the squares or absolute values or square roots or cube roots or any weird stuff that's up there. All the symbols have to stay. All I'm doing is getting rid of all the letters with parentheses. So each letter becomes an empty set of parentheses. Okay.
So what you're demonstrating basically is that the variables aren't really of any consequence. It's more or less
The setup.
the
The setup. The setup is really important. It tells you what you're going to do to the numbers. All right, so the first set of parentheses is x, and x is equal to? Negative 2. All right. Another reason I use parentheses. You remember this from Tuesday? What's negative 3 squared? Oh, you all just said you remember this from Tuesday. What is it? Negative 9. Negative 9. So this parentheses around this negative 2 is keeping us away from that possibility. If you type it into your calculator, negative 3 all squared, it'll give you negative 9. But this is supposed to be positive 4. So it preserves the correct operation that has to happen there. All right, this is y. Y is negative 1, and this is z, and z is negative 3. And again, it preserves an operation in both of these cases. Here, it preserves the multiplication. Here, it preserves a negative times a negative. Again, multiplication. This is x again, negative 2. This is z, negative 3. After you substitute, order of operation kicks in. You know, please excuse my anti-rain and all that fun stuff. So let's see here. Squares first. Negative 2 squared is?
4.
Positive 4. Positive 4 times negative 1? Negative 4 times 3?
Negative 12.
You get negative 12. Negative times a negative, of course, is a positive. 2 times negative 2? Negative 4. Plus negative 3 all squared? 9. Now, I've run into problems where I'll write plus here, and then all of a sudden this number turns out to be a negative number, and it messes things up. Try not to write plus minus, because that makes absolutely no sense. It really does. I've seen people do it. They'll write plus a negative 3, and technically that makes absolutely no sense. If you're going to do that, it has to be in parentheses. I hope that doesn't get in the way. No, it shouldn't. Negative 12 plus 3? And negative 4 plus 5? Negative 4 plus 9. I was given the answer. 5. Woo-hoo. I'm so smart. Sometimes I think ahead of, I say things before never mind. So that's evaluation. Replace all the variables with parentheses, then worry about plugging in the values. That way you don't make any mistakes. Now, another little comment. A lot of people like typing this junk into their calculator. You got to be careful. When you see these long fraction bars, they are an ancient, well, not ancient, but an older notation for grouping. You have to be very, very cautious with it. Modern day would write something like this to represent grouping around the 2x plus 3 and then x minus 4, and we're going to multiply them together. A couple hundred years ago, it would look like this. And they would use long bars on top of them to group them. Now, we still use that notation in certain cases. One of those cases, long fraction bars. So if you have something like 4x minus 2 over 5, then the grouping is happening to the top. So what's invisible here is there are parentheses around the 4x minus 2. They're there, it's just that that long bar is taking care of it. So if you get confused with these long fraction bars and where parentheses go, put them in to begin with, and then you usually aren't going to make any mistakes. So if you were going to type this, the entire expression, into your calculator, how would you do it? The first thing you'd have to start off with is a parentheses on the beginning of the top, a parentheses at the end of the top, a parentheses at the beginning of the bottom, and a parentheses at the back of the bottom. And you type it in exactly the way this looks into your calculator. I don't mean identical. So you'd write parentheses 3, parentheses negative 2. Negative is the little sign, not the minus sign, it's down at the bottom. End parentheses, square it, parentheses negative 1, parentheses, and you just type it in exactly the way it looks, and you hit equals, and you'll get a decimal for negative 5/9. And then you can always change it into a fraction in your calculator. I don't suggest that you do that. My suggestion to you is type the top in, get an answer, type the bottom in, get an answer, and then just keep it as integer over integer. The other thing that I want to talk about is some people, when this expression gets a little bit longer or it turns into an equation, it gets very confusing what to do with this 5 in the bottom. One thing you can do with it is change it into a product instead of dealing with a quotient. Remember, division and multiplication are the exact same operation. So dividing by 5 is the same thing as multiplying by 1/5. That comes in very handy, and I'm going to do it a few times throughout the semester for those people that like that style better, because for some people, this is nicer. Why? Well, if it was 4x minus 2 divided by 5, and I want to multiply by 10, this expression, just for the fun of it, I've had people, they'll do the 5 goes into 10 twice and get the right 2, and then they'll distribute the 10 through the top, which actually makes absolutely no sense. So if they wrote it this way, and you put the 10 out front, how do you multiply 3 numbers together? No. How do you multiply 3 numbers together? 2 times 2 times 4. Oh. What property is that? Oh, come on, I taught this on Tuesday. Associative. Anytime you're multiplying 3 things together and you choose to multiply 2 of them first, that's the associative property. So you would group these 2 together, times 10 times a fifth is 2. So you get 2 times the quantity, 4x minus 2, and then you can go on your merry way. So this notation, pulling the fraction out front, sometimes saves you a lot of headache. Sometimes. It'll be a little extra writing, but it will save you a lot of headache. It'll guarantee you get to a better answer. It's different. Most people don't see it that way, though, but that's what you're supposed to look at. Is that all my notations? Oh, square roots. Another place where the long bar comes into play. How many of you have ever written something like this on a test? Teachers look at that and go, what the heck do you mean? Are you taking the square root of x plus? That makes absolutely no sense. Is it the square root of x plus 2? This line on top is another one of those grouping symbols. It's supposed to cover everything that's supposed to be in parentheses. Calculators today write it this way. If you type in a square root into a calculator and there's more than one term, the calculator gives you the first parentheses, you just have to put in the last one. So that line, I wish they would do it, just extend the line over all the stuff. I think the fancier calculators will do it, but not the lower level ones. So you got to be really careful. If you really mean the square root of x plus 2, you better write it so that the line is covering everything. One thing you should do if it is the square root of x plus 2 is supposed to be that. I highly suggest you write it backwards. That way there is no way of mistaking where that 2 belongs. It's outside the square root. Technically, square root should be the last thing you write whenever you write an expression or a solution or anything like that. Okay, so that's notation. Let's get into the fun stuff.